We're continuing our work in 6.9, working on integration. And in some of our past examples, we learned that we could either back substitute your expression in terms of x or keep it and keep the original boundaries, or you can keep your answer in terms of u and change the boundaries. So it's really up to you. However, the AP exam does like to ask you questions in which you change the boundaries. So it's really a good skill to make sure that you have that. So this is a question that's an example of that. So if the substitution u equals x over 2 is made, the integral of this, okay, basically which one of these is the answer. So I know that my u is the x over 2. So I know I'm going to substitute u into that, and then I'm going to have to figure out what that x is. So I'm going to start rewriting my integral. Minus parentheses squared over x. I don't need the dx. So I know I'm putting the u in here. I know I'm going to have to solve this for x. So I'm going to multiply both sides by 2. So I get 2u equals x. So this is going to become 2u. Okay, I kind of think I already know the answer, but we want to double check. I need to take the derivative of this. So the derivative, this is really like saying u equals 1/2 x du equals 1/2 dx. Oh, so I don't know the answer. I don't think I have the right answer. I need to multiply both sides by, or I'm going to actually multiply by 2 over 2 here because I needed that 1/2 to come in. So I know I need to bring this denominator 2 actually inside the function there. Before I integrate. So let's actually do that, rewrite this and do that. So I have a 2 hanging out in front. I have a 1/2 in front of the function, and that's 1 minus u squared over 2u, and then du. I'm missing the du at the back. Now, this 2 right here, so this 1/2 was part of the u substitution part, okay? But this 2 could very easily have been brought out front. So I could take this 2 and bring it out front. So that means I would have the 2 that's already there divided by this pink 2, and then the integration of all this other mess. And this is just part of the u substitution, so I really wouldn't see it in the final integration piece. So these 2's are going to cancel and just become a 1. So we're almost there. Look, now we've narrowed it down to it has to be one of these 2. But I need to change my variables of integration. So my original was 2 and 4. I'm going to substitute into this. So I've got u of 2 equals 2 over 2, which is 1. So my bottom one should be 1. And then u of 4 equals 4 over 2, which should be 2. So my top one should be 2. So it should be answer choice D. Let's take a look at example 11 as well. The twice differentiable functions f and g are defined for all real numbers. For values of f of x and g of x for various values of x are given in the table below. We are supposed to evaluate from 0 to 5 of g prime of f of x of times f prime of x. So we definitely have our chain rule kind of going on inside there. So we can see that we definitely had a u substitution. It kind of looks like a chain rule. So our u value is actually going to be this. So u equals f of x, which means that du is equal to f prime of x dx. So I have all of that. So I'm going to go ahead and I'm going to substitute in. So we've got 0 to, oh, no, I'm not going to do 0 to 5, am I? Let's not do that. So we've got g prime of my u value, and then times du, because I can replace f prime of x dx with du. Now, because I'm in u's, I have to change my variables of integration. So I'm going to plug those into my u over here. So I'm going to find u of 0, which is going to be f of 0. That's why they gave us this table. F of 0 is 1. Now I'm going to find u of 5, because that's my upper limit of integration. So I'm going to look for f of 5. What do you know? It's 3. So my upper limit is 3. And we actually have to keep going until we have it evaluated. So I'm now going to integrate it. When I integrate g prime, I get back to g of u, and I'm going to go from 1 to 3. So we're going to plug in the 3. So g of 3 minus g of 1. I'm going to use the table to figure those out. So g of 3 in the table is 3. G of 1 in the table is 10. So it looks like my answer is -7.